So we've already done LRAM, RRAM, and MRAM. Now we're going to talk about lower Riemann sum and upper Riemann sum. Okay, relax. This is not tested on the AP exam, but it is tested for universities. So that's why I'm bringing this up. By the way, this is coming from UH, so you can already see what's going to happen in a little bit. Not today, but we're getting ready for another one, another UH one. It's actually not too bad, not too heavy with algebra. All right. So it says, example one says compute the so underline lower Riemann for the given function f of x squared over the interval negative 1 to 1 with the partitions negative 1 to negative 1/4, 1/4 to 1/2, negative 1/4 to 1/2, 1/2 to 3/4, and 3/4 to 1. The key word is lower. You're going to get the lowest point on the curve, and that's how you're going to make your rectangle. So I'm going to exaggerate this function, x squared. So here's me exaggerating x squared. So exaggerate x squared. Oh, it's not bad. Here's negative 1. Here's 1. Let's see. Negative 1/4 is probably like, bam, negative 1/4. And then 1/2 is halfway, so half. And then 3/4 is halfway between 1/2 and 1. Okay, there it is. Those are my partitions. Between negative 1 and negative 1/4, between the x values, negative 1 and negative 1/4, what y value is the lowest on that specific partition? At negative 1/4. Do you guys see that? So that's my rectangle because it's a lower Riemann sum. So you'll see right now. You'll see right now with this one, with this next one. Between the next partition, between negative half, negative 1/4, and positive half, I'm looking for the lowest y value. And it can be anywhere between negative 1/4 and a half. So where is my lowest y value? Where? At 0. So technically you don't have a rectangle, but so you guys won't get lost, draw this. See? There's my rectangle. Area of 0. Because it's a lower Riemann sum, the lowest point, the lowest y value on that partition. The lowest y value on that partition is at 0 because it's 0. No, the partition between negative 1/4 and a half. See, these are my partitions. Negative 1 to negative 1/4, that's a partition. Negative 1/4 to 1/2, that's a partition. Do you know what I mean? Okay. The next partition between a half and 3/4. The lowest y value on that curve happens when x is a half. So there is my rectangle right there. Do you guys see that? And then my lowest rectangle, my lowest y value between x equals 3/4 and x equals 1 happens when x is 3/4. So there it is. Cool or not cool? Are we okay, guys? All right. All I'm doing is width times height. The difference between negative 1 and negative 1/4 is 3/4. So I write 3/4. And then the height is dictated by that negative 1/4 squared because it's a function f of x equals x squared. So negative 1/4 and I square it. I suppose you can take out the negative if you want, but I'm just being technical here. The next one, the distance between negative 1/4 and 1/2, and I know that's a 0, guys, but I just want to show it. That is 3/4, right? 50 cents plus 25 cents. And 0 squared. I know that's 0. Plus the distance between a half and 3/4, that is 1/4. And the height is dictated by 1/2 squared. Plus the difference between 3/4 and 1 is another 1/4. That's the width. And the height is dictated by 3/4 squared. How do we feel? Do we feel okay, guys? Okay, take your calculator and let's find what that is. And quit. And let's see, 3/4 parenthesis negative 1/4. I guess you don't have to, like I said, put that negative there. Squared plus 0 plus 1/4 1/2 squared. Plus 1/4 3/4 squared. I got 1/4. Is there a 1/4 in there? There it is. How do we feel, guys? Okay. Go to the next one. It says compute the lower Riemann sum for the given function. I have f of x equals sine x over the interval 0 to pi with respect to the partition, and they tell us how they partition it. So I'm going to exaggerate sine x. So it's baby pre-cal. It's not extreme. So here's sine x. Let's see. I didn't do it perfect. That's fine. 0 pi. All right, let's see what my partitions are. From 0 to pi over 6. So pi over 6 happens pretty quickly. So right somewhere like right here. Pi over 6 to 3 pi over 4. 3 pi over 4 is in the middle between pi over 2 and pi. So probably like here's pi over 2. So probably like right there. 3 pi over 4. And then 3 pi over 4 to pi. There it is. Pi over 2 is not part of the partition. All right. What do they want? Upper or lower? Man, I should have done an upper one. They want a lower. So you pick the lowest point. If it says upper, you pick the highest point on that partition. So between 0 and pi over 6, where do I have the lowest point? 0. So you don't really have a rectangle. It's that green line right there. Between pi over 6 and 3 pi over 4, where do I have the lowest partition? At pi over 6. Here's how it's going to look like that, guys. You guys see it? And then between 3 pi over 4 and pi, where's the lowest y value? At pi. So you don't have, so there it is. You just have that one rectangle. It's not extreme pre-cal, guys. Relax. It's just geometry. The width, all I'm doing is width times height. The width is 3 pi over 4 minus pi over 6. And the height is sine of pi over 6. So here we go. Area equals, parenthesis, 3 pi over 4 minus pi over 6. I guess you could tell the calculator to go 3/4 minus 1/6 and then turn it into a fraction, but we're not going to do that. We're going to do it by hand. Times sine of pi over 6. What's sine of pi over 6? I don't know, job. Yeah, 1/2. I think I heard someone say it. You know, it's not extreme pre-cal, guys. Make sure you know your unit circle. All right. How do I do this? By hand. Common denominator, guys. It looks like my common denominator is going to be 12. So I'm going to multiply this guy here by 3 over 3. And I'm going to multiply this guy here by 2 over 2. So when I do that, I'm going to get 9 pi over 12 minus 2 pi over 12 times half. 9 minus 2 is 7. So what I see 7 pi over 12 times half. So I see 7 pi over 24. If you have issues with fractions, you could always just do 3/4 minus 1/6 in the calculator. You could always just do this. 3/4 minus 1/6. Push enter, turn into a fraction, and put a pi on the top. See? 7 pi over 12 times half, 7 pi over 24. How do we feel, guys? Okay. Now for this. If you've had statistics, this will be really easy for you. It'll be like a walk in the park. If you haven't had statistics, it's still easy if you just put a little bit of thought and practice. You guys ready? It says let's get acquainted with what sigma notation is. So we check out this sum below. Sometimes they call this a sequence. Okay, we'll not talk about that because, this. Okay, 1 over 1 plus 1/4 plus 1/9 plus 1/16 plus 125 plus 136. There's an obvious pattern to this sum, and we call it a sum because there's a plus in the middle for all of them. The terms in the sum are reciprocals of squares. Written in sigma notation, you could write it. So what is this right here? So that j equals 1 is called your start term or your start, and the 6 is your end. And when it says, so I'll write it right here. It says this is not the only way to write the expression. I can think of other ways. Well, first let me write this one. So sigma, this is called a sigma. J equals 1 to 6. So remember, that's a start. And this is the end. So of 1 over j squared. Well, that means this. 1 over 1 squared. That's n equals 1. Or j equals 1. That's j equals 1. Plus 1 over 2 squared, that's j equals 2. See, you're just going to keep going until you get to 6. Plus 1 over 3 squared, plus 1 over 4 squared, plus 1 over 5 squared, plus 1 over 6 squared. And you stop there because it says end. And that's how those work. And that's called sigma notation. That's called sum, that E. Sometimes they use the letter N. Sometimes they use the letter I. It just depends. Does that look familiar to you guys? And we're always talking about integers. There's no such thing as n equals 0.5 or n equals 0.3. You're talking about whole numbers. See? 1, 2, 3, 4. You're just counting, literally. Cool or not cool? You don't have to start at 1. It says it's not the only way to write this expression. We could have written it. So let me change my color so you can see it's a different. It's a different. I'm going to start it. Let me see. I'm going to use the letter N. I'm going to start it at 0, and I'm going to stop at 5. Because I have 6 terms, and if I count it 0, right? And I'm going to go 1 over, and I'm going to call it n plus 1, close it squared. See? That will give me the same answer, guys. If n equals 1, n equals 0. Sorry, I got to start at 0. If n equals 0, I get 1 over 0 plus 1 squared. Plus, if n equals 1, I get 1 over 1 plus 1 squared. Plus, if n equals 2, I get 1 over 2 plus 1 squared. Plus, if n equals 3, I get 1 over 3 plus 1 squared. Plus, if n equals 4, I get 1 over 4 plus 1 squared. And finally, if n equals 5, I get 1 over 5 plus 1 squared. Well, notice, and I'll zoom in. Look, this is the same thing, guys. 1 over 1 plus 1 over 2 squared, so 4, plus 1 over 3 squared, which is 9, plus 1 over 4 squared, which is 16, 1 over 25, 1 over 36. That's what this was over here. This was 1, this was 1/4, this was 1/9, this was 1/16, this was 1 over 25, this was 1 over 36. So there's more than one way to write equivalent expressions. Nothing crazy, right? Are we still okay, guys? Okay, that's all we're doing today. We're just practicing. See? So maybe we could have done two lessons in one day, but too bad. I already. So we'll just stick with this. All right. From 1 to 6. And don't worry, in a little bit I'll show you how to do it with a calculator. From 1 to 6. 1 plus 2 plus 3 plus 4 plus 5 plus 6. 6 plus 5, 11 plus 4, 15 plus 3, 16, 17, 18, 19, 20, 21. Chab, is there a faster way to do this? Is there a faster way? Of course there is. There always is. You have a calculator, right? Check out your calculator. Click on the math button and scroll down until you see something that says summation. Do you see it? Click on it. OMG. You could use the letter N or A if you want, but I'm going to just stick to X. X, and where do I start it on this one? X starts at 1. So 1. Put a 1 in the wrong one. X starts at 1, and then where does it end at? The very first problem, 6. And it's just I, so this is just, I'm just going to type in X. And voila, should be the same answer. Cool, right? Okay. There you go. Now you guys know how to use it. All right. Check it out. Just like before, you can have the summation. You can have this expression equal 21 again and look at different. Look where it starts now at 0. It's still considered the first term, 0 plus 1. 0 plus 1 plus 1 plus 1 plus 2 plus 1 plus 3 plus 1 plus 4 plus 1 plus 5 plus 1. And I know, guys, I'm just showing out. I'm just writing it out. 1 plus 2 plus 3 plus 4 plus 5 plus 6. That's just like before. 21. Cool or not cool? Cool. All right, here we go. Where am I starting at? 3. So I'm going to go 3 squared plus 4 squared plus 5 squared plus 6 squared plus 7 squared. Whatever that sum is, it's some number. I'm not going to add it up. That's not the main point here. The main point is how to use it. All right. Chop, this one has 2 variables. Okay. You're going to have a 1 over n for each one. And then you're just going to move the k from k equals 1 to n. And you show 3 dots to iterate. By the way, you can already see what's going to happen here, how it's going to look like what that limit thing tomorrow. So look, check it out. I'm going to start at 1. 1 over n, parenthesis, 1 squared plus 1, close it. What's the next term? If I started at 1, 2. But that n is an n, and I don't have, so I'm just going to keep 1 over n. That's an n, not an h. Parenthesis, 2 squared plus 1, close it. What's the next term? 3, right? 1 over n. 3 squared plus 1, close it. See how it just keeps going? So you're going to put plus. You're going to put 3 dots. 1, 2, 3. In BC, this is super important. But for now, in AB, it's not really that important because we're going to not mess around with series too much. And then I'm going to put a plus, meaning that the pattern keeps going. And then I just put the last term. Usually we put the last 2 terms, but we're rookies. We're just going to put the last term. The last term is n. 1 over n, parenthesis, n squared plus 1, close it. You can leave it like that. That's perfectly fine. I just want to make sure, I want to give you the best education possible. Do you see how every product has a 1 over n? I can factor out that 1 over n. 1 over n, giant parenthesis. 1 squared is 1. 1 plus 1 is 2. 2 squared is 4. 4 plus 1 is 5. 3 squared is 9. 9 plus 1 is 10. Plus dot, dot, dot. Parenthesis, n squared plus 1. That's an n. Close. That's my last term. We're okay? Yeah, sometimes you'll see, maybe we should be putting the last terms n minus 1 and then n, but we're fine. We're fine. Okay, letter E. Yeah, we're summing. This is actually, okay, we're kind of getting ahead of ourselves, but I want to put this picture in your brain. What you see here, this f of x, that acts like a height. This delta x acts like a width. What are you talking about, Chop? Well, isn't f of x equal to some y value? Like if I tell you f of 3, that's a y value, right? So this is what we're going to be doing tomorrow. We're going to be adding rectangles. And we're going to be adding an infinite amount of them. See, so you can already see I'm going to be putting a limit. So I'm doing width times height. Or this is the width, and that's the height. Width times height, width times height, width times height. And that's all you're doing. So I put that in there. So I just want to put that in your brain. Chop, what are you talking about? I'm talking about rectangles like what we did 2 days ago. Did we do LRAM, MRAM, RRAM? Yeah, we did, right? And remember how we added those rectangles? So now we're adding a good amount of them, a lot of them. But I'm just getting ahead of myself. That's what we're doing tomorrow. That's why I need your A game tomorrow, because the concept is we're going to be putting a lot of rectangles. How many? An infinite amount. We're not there yet. We haven't written limit or anything like that. That's for tomorrow. So bring your A game tomorrow. Get your sleep. So here we go. I'm going to start at 1, and I'm going to go approach to n. F of x1 delta x plus f of x2 delta x plus f of x3 delta x plus dot 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 f of xn delta x. This is Chavez. Okay. Mm-hmm. That's for you, Ms. Rodriguez. Did you know? Oh yes. There needs to be a plus. Sorry, the phone rang and it messed me up. It threw me all out of cycle. Man, that coffee works. Okay. Are we okay so far? No, that's like a different blend or something my sister gave me. Okay, here we go. What do all these products have in common? What do all these products have in common? What? So I can factor out the delta x, f of x1 plus f of x2 plus f of x3 plus dot 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 plus f of xn. Close. Not too shabby, right? Okay. Go to the next one, guys. Relax. We're good. This means let's just start at 1 and approach 5. F of 1/2 plus 3 plus f, and I'll write it out. 2 over 2 I know is 1, guys, but I'm going to write it out so you can see what I'm doing. Plus f 3 over 2 plus 3 plus f 4 over 2 plus 3 plus f 5 over 2 plus 3. Let's see if we can do this really quick. 3 plus half is 3.5, so f of 3.5 plus f of 4 plus 3 over 2 is 1.53, 4.5, f of 4.5. So it's all going to be going by 0.5, as you can see, plus f of 5 plus f of 5.5. Shav, how am I going to do that so fast? You don't. I mean, I guess you can, but I would just type it into my calculator like this. This one, that might be. I'm not saying it's a headache, but right now it's the end of the day. Negative 2x. What was it? Plus 3? Like that? Let me look at it. Negative 2. Yep. So I'm just going to type this into y1 like this. Clear. Alpha trace y1. And what was the first one? 3.5? Plus alpha trace y1, 4, plus alpha trace y1. All right, bird. I think that's a youngin, right? Asking for to be fed or something. And we were all like that once. You guys were all babies asking for food. Yeah, don't have kids. I'm kidding. I'm probably better delete that, huh? From this video. 250. Remind me. Okay. Enter. Negative 30. You will not be reminding me? You think I should leave it? Okay, we'll leave it. We didn't say anything offensive, right? It's meant with love. Yeah, it's just birds. We're not. No, but we're talking about humans. Well, we're all babies. We're all at one time. All right, guys. This sum. Could I have just typed that in? Yeah. Look, let's see. You could have just gone math number. What number is it? 0. X equals. Where did it start at? Was it 1? And when did it end? 5. And then you could have just typed this, guys. Alpha trace y1 open parenthesis. Look, I'm going to make it look exactly like that. I'm going to put a little fraction feature here. I'm going to put the x there. I'm going to put a 2 down here. I'm going to put a plus 3. Look, there's my function right there. F of x, k over 2 plus 3. Close it and push enter. OMG. Cool, right?
Do you ever have like a non-calculator
Oh yeah, they have non-calculator questions all the time. Yes. If you were to be taking the Cal BC exam, you would be doing. If it has a sum, there's always partial sum series with partial sums. But if you have infinite terms, if it's a geometric series, it has a sum. And then for others, it's you need more math to figure out the sum, but you know that it converges, and that's what Cal 2 is all about. Not all of it, but a good chunk of Cal 2 is about that. It's Unit 10 or Unit 9, whichever one, the one that says series and sequences. It's actually a lot of fun. You're going to learn it because we're going to be doing BC, right? Yeah, we're going to need to make a game plan because we're getting behind by the day. So we're going to have to make a big game plan to meet up at least once a week, twice a week. All right. This one here, guys, I think this one's easy enough to do by hand because, look, there's only 4 terms here, 1, 2, 3, 4. And notice that I have x minus 4 here. So I'm going to go f, and then I'm going to plug in 1. 3 times 1 is 3. 3 plus 3 is 6. So I'm going to write f of 6. Plus f, I'm going to do the 2 one. 3 times 2 is 6. 6 plus 3 is 9. So f of 9. Does everyone know where I'm getting these numbers from? Right. And then the third one, 3 times 3 is 9. Plus 3 is 12. So it's just going up by 3, 6, 9, 12. And then the last one, 3 times 4 is 12, plus 3 is 15. And because this one is pretty straightforward, it's just x minus 4. Look, 6 minus 4 is 2, so 2. 9 minus 4 is 5, so 5. 12 minus 4 is 8. And 15 minus 4 is 11. See? So let me know if I made a mistake. Did I make a mistake anywhere? 11 plus 8 is 19, plus 5 is 24, plus 2 is 26. And there it is. How do we feel, guys? All right, we're done. You just have one little delta. It's probably the shortest delta ever. It says estimated time, 17 minutes. So you're done, guys. That's it.